In this video, we're going to look at average velocity and how it differs from average speed. So average velocity is going to have a very similar formula to speed. So we're still going to use the letter V, but this time we're going to put a little arrow over the top. That arrow tells us that velocity is a vector, meaning it has direction. So we're going to have our velocity is going to equal to our change in displacement. So similarly, was distance for speed. This is now displacement because it's a vector. So we have change in displacement, and that's going to be divided by the change in time. Time is not a vector quantity, time is scalar, so there's no need to put the arrow over top. Time does not have a direction. We're going to look at this example now where we are asked to calculate the average speed and the average velocity for the same movement. So a student walked from her bedroom to her kitchen to grab a snack and then to her living room to attend virtual class. The distance between her bedroom and kitchen is 7.5 meters. So I'm going to underline anything about a distance in blue, and that's going to be for our speed calculation. So 7.5 meters. And the distance between her kitchen and living room is 4.5 meters. The displacement, so I'm going to underline anything with displacement in green, and that will be for our velocity. The displacement between her kitchen and living room, her bedroom and living room, is 8.75 meters to the southeast. Now we're going to use the same time for both. So when the student left her bedroom and entered her living room, 4 minutes had elapsed. So we're going to be able to calculate both speed and velocity, and I'm just going to draw a line down the center here. So to start with speed, we need distance and we need time. So our distance is going to be the total distance she walked, which is 7.5 meters plus 4.5 meters. So in total, the student walked 12 meters. This journey took 4 minutes. Now we're going to put that into seconds, so we have a speed in meters per second. So we're going to multiply that by 1 minute, and there's 60 seconds. And so this took 240 seconds. Our speed then, speed equals distance over time, is going to equal 12 meters divided by 240 seconds, which equals 0.050 meters per second. And so that is our speed. We're going to do a similar calculation for our velocity. So here our displacement is 8.75 meters southeast. And our time is 4 minutes, and we already know that that's 240 seconds. So no need to do that that unit conversion again. So our equation for velocity is displacement over time. So that's going to be 8.75 meters southeast divided by 240 seconds, which is going to equal 0.036 meters per second, and that direction is going to be southeast. So the average velocity that our student traveled is a little bit lower than the average speed. So that's our velocity here.